Welcome to this Maths Made Easy video on the standard normal distribution. To start with, let's take a look at why we use the standard normal distribution. One reason to use the standard normal distribution is to solve probability questions that could otherwise be difficult for a calculator to handle. So for example here, we've got our normal distribution for the random variable x, and we're asked to solve this probability question. So how would we do this here? Well, to start with, let's consider our definition of the probability here. So here we can write the probability, and we've got two parts to this. We've got the lower bound of this probability and the upper bound. So in that case, if we start with the lower bound here, we can write this as 999,500 minus mu, and we divide this by sigma. Okay. Remember, this is for the z values here. So our upper bound then, this is going to be the upper bound value, 100, 1000 minus mu, and again we divide this by sigma. So here now, what we do is we simply substitute our values of mu and sigma into this probability here. And remember, from our normal distribution, this value here represents the parameter for mu, the mean, and this value here represents the parameter, the variance, okay, which is sigma squared. So when we want to input sigma here, we need to square root this value. So if we input these here, that will give us the probability of 999,500 minus mu, which is this value here, so that's 1000, another 3 zeros there, and we divide this by sigma, which is the square root of this value here, so the square root of 122,500. Okay, so that gives us the lower bound there. Now we just consider the upper bound here. And in that case, it'll be the same, but again, we just replace mu and sigma with the appropriate values. So minus 1000, over 3 zeros. So that gives us mu. We divide here again by the square root of 122,500. Okay. That gives us the upper bound then for our probability. And here now, if we just simplify the lower bound and the upper bound of these probabilities, we can write this probability as minus 10 over 7 for the lower bound, and for the upper bound, this is 20 over 7. Okay, and if we now just evaluate this probability here, what we find is this is equal to 0.9213 there. Okay. So that gives us the solution to our example there. Now another reason to use the standard normal distribution is that you will be provided with a table of key values for it, and we call these the percentage points table. And the percentage points table is most useful for finding z values from probabilities. So let's clear everything we've got so far, and let's consider another example here. And let's do this in another pen colour just to make it clear. So let's say we've got another distribution here, x, which is also a normal distribution. And let's say our mean here, mu, is 10, and our variance is 9. And we know the probability of our random variable x being less than a value little x is equal to 0.95. And we just want to find little x here. Okay, so just find little x. How would we do this? Well, we just consider our definition then for the probability. So we write this as the probability that z is less than x minus mu over sigma. And we know this is equal to 0.95, like we stated here. Okay, so like we stated here, this is equal to 0.95. And remember, we know the value of mu. This is mu here, and this is the variance. Okay, so that's sigma squared. So remember, we need to square root here for our denominator. So in that case, we write this as the probability that z is less than x minus 10, because mu is 10, and then we divide this by 3 here. The square root of 9 is 3, and that's still equal to 0.95. So now, from the percentage points table, we find that x minus 10 over 3 is equal to 1.6449. So all we want to do now is solve for x. And in that case, if we multiply the left hand side and the right hand side here by 3, we get x minus 10 is equal to 4.9347. And finally, if we just add 10 to the left-hand side and the right-hand side here, we get x equals 14.9347 there. Okay, and that gives us the solution to our second example there. And that gives us everything we need for why to use the standard normal distribution. Moving on now to take a look at transforming to the standard normal to find an unknown. Now the biggest reason to use the standard normal distribution is that doing so can help us find mu and sigma if one of them is unknown. So let's consider this example here. We've got our distribution for x, where we've got mu, and we've got the variance of 4 here. And we're told the probability of x being less than or equal to 31 is 0.9. We just want to find mu now. So this is why we would use the standard normal distribution. So to start with here, let's just write our probability. So this is the probability that z is less than or equal to 31 minus mu. Because remember, we don't know what mu is, and then we divide this by the standard deviation sigma. Now this is sigma squared. So remember, we square root this value here. So the square root of 4 is 2. So we half this value here. And we know this is equal to 0.9. So now, from the percentage points table, what we get then is 31 minus mu over 2 is equal to 1.2816. Okay, so now we just want to solve for mu here, so we times by 2. So we get 31 minus mu is equal to 2.5632, and therefore mu is equal to 31 minus 2.5632 there. Okay, and if we evaluate this for mu, we get 28.4368 there. Okay, so 28.4368. Now, if sigma is unknown instead of mu, we can use the same method to get an equation in that case. Okay, so that's how we would do it if sigma was the unknown variable there. So that gives us everything we need for transforming to the standard normal to find an unknown. And finally, let's take a look then at simultaneous equations from the standard normal distribution. If we are given two probabilities, we can convert to the standard normal distribution and use the percentage points table to get two equations. And in that case, that would give us an ability to solve for two unknowns. This means that we can find both mu and sigma. So let's take a look at this example here. Suppose x is a normal distribution with parameters mu and sigma squared. We're told the probability of x being less than 0.2 is equal to 0.05, and the probability that x is less than 0.9 is equal to 0.8. And we want to find mu and sigma. So again, let's just consider writing our probabilities out. So if we start with this first probability here, okay, so we'll do this in our original pen colour here, well, we can say then the probability of z being less than 0.2 minus mu divided by sigma is equal to 0.05. Okay, we can't do anything with mu and sigma. We don't know what those values or those parameters are. Okay, so we just use mu and sigma. But now we can use the percentage points table. So here we obtain that 0.2 minus mu over sigma is equal to minus 1.6449. Okay, and in that case then, if we multiply the left hand side and the right hand side of this equation by sigma, we get 0.2 minus mu is equal to minus 1.6449 sigma. Okay, so that's our first equation. Okay, so let's denote that as equation 1. And now let's write our next equation out. Okay, and we'll do that in this orange pen colour. So now we're considering the probability that x is less than 0.9 is equal to 0.8. So in that case then, again, using the same definition here, we can write the probability that z is less than 0.9 minus mu over sigma here is equal to 0.8. Okay, so it's equal to 0.8. And again, we just use the percentage points table now. So we can say that 0.9 minus mu over sigma is equal to 0.8416. And again now we just times the left hand side and the right hand side of this equation by sigma. So we get 0.9 minus mu is equal to 0.8416 sigma. Okay, and this gives us equation 2. So what we've got now is two equations with two unknowns. So we can solve these simultaneous equations. And what we'll do here is we'll clear everything we've got on the screen so far, but make sure to take note of both these equations if you don't have them already. So to finish with them, let's consider both the equations that we've got and let's solve them simultaneously. So if I do equation 2 minus equation 1 then, what I'd obtain then is 0.7 is equal to 2.4865 sigma. Okay, so therefore we can obtain our value for sigma. So therefore sigma is simply equal to 0.2815. Okay, and then clearly once we've got our value of sigma, we just substitute that back into one of the equations, either equation 1 or equation 2. Of course, it doesn't matter which one. So if we substitute this in then, let's say we get 0.9 minus mu here. That's going to be equal to 0.8416 times by sigma, which is 0.2815. So times by 0.2815 there. Okay, so therefore 0.9 minus mu is equal to 0.2369. And remember, we just want to solve for mu here. We've already found sigma. We just need to find mu now. So therefore mu is equal to 0.6631 there. Okay, and that means we found mu as well there. Okay, so that gives us the solution to our example, and that gives us everything we need for simultaneous equations from the standard normal distribution. And that concludes this Maths Mini video on the standard normal distribution.